Welcome everybody, and welcome back to our mini-series on data visualization. Last month, we spoke a little bit more about the theoretical part of data visualization, and today we want to follow up with hopefully some more practical information for you. So before we get started, I still hear some background noise, so if you could all make sure to be muted while we give this presentation, and then we will open the floor for Q&A after each of the parts of the webinar. So before we get started, I would like to briefly remind you who we are. GHGA stands for the German Human Genome-Phenome Archive. And our mission is to provide a platform for GDPR-compliant human omics data sharing. And this will allow secondary use of clinical omics data in research and translation of research insights. And as we hope to interact with a lot of different communities, we bring on these webinars to kind of get together all these different communities and talk about scientific topics that matter to us. All of our training is recorded, just like this webinar here, and you can find all of that on demand on our website as well as on our YouTube channel. And that leads me to the next point. This meeting is being recorded. However, none of your audio or video will be included in the final video. So feel free to unmute if you have questions. And now I want to briefly introduce our speakers today. You already know me from last time. I'm the training coordinator at GHGA, and I will be giving this webinar today with Gian, who is joining me. She is in the last couple of weeks of her PhD in bioinformatics at the Technical University in Braunschweig. And she is now a bioinformatician, chair for computational molecular medicine, and a data steward at the Munich Data Science Institute. And so with that, I think we can get started on our practical guide to data visualization. As a very quick recap from our last webinar, we talked about data visualization as a form of communication and kind of the four key concepts that you want to consider when doing data visualization. So we have the data itself and the quality of the data, the type of visualization that is appropriate to your data, the audience that you're presenting to, so the level of interest and understanding, as well as the need for accessibility and inclusion, and also the location and context that you're presenting this visualization in. There's this whole video on it, and the slides are public as well, so if you feel like you missed out, you can always go back and watch that. Since we're doing a little bit more practical stuff today, I want to briefly introduce the example data set that we're using. We're using the Palmer penguin example data set. You see a little overview of what's included in the set here. So we mostly have 3 different species of penguins that we're working with. Their data has been collected from, I think, 3 different islands. And we have some numerical data here, such as bill length, bill depth, and flipper length, and body mass, as well as the sex of the penguin and the year the data was collected. So this is the data set that we will be playing around with, which is also publicly available. You can find that, and you can load it in both R and Python. And so what we want to cover today is we split it into parts. So we'll talk about R in the first part, and then we'll allow some time and a break for some Q&A, and then we will move on to Python. And in the R part, I want to cover base R plotting, the concept of grammar of graphics, and all the different customizations that it will allow, and then also briefly introduce you to interactive data visualization. And in the Python part, we have a very similar setup. We'll introduce you to the more basic libraries that you can plot with in Python, and then the more advanced and more customizable ones. Then there's also a library that will allow the grammar of graphics concept for Python, and then also interactive visualizations. So base R plotting works just the way you can see here. So in the most simple way, you will have a one-line command just with the command plot, where you specify what's being plotted on the X and Y axis, and then R will just turn this into the most basic scatter plot there is. And so base R works in this sort of canvas model, meaning it assumes that you have a blank canvas and you layer information on top of it, sequentially fill the canvas. And this is really great for quick data exploration. So let's say you haven't worked with the Penguin data before, you have no idea how many data points there are and what they look like. It's a really great way to just get an overview. However, if you want to start making more complex and more customizable plots or visualizations, you'll notice that it gets a little bit clunky and slow. So one of the reasons is that you have to make all of your design assumptions at the very beginning and then kind of customize this one plot function with all the different information that you need. So we've kind of looked at a scatter plot here, but like another example is if now you wanted to go and do a histogram of the same data, then you would have to use a different function to achieve this. And this different function might also have different parameters and different settings that you can use. So if you were just to remove the plot and then put hist in front of it, you might not be able to actually plot because the parameters are different. So that's a little bit of the drawback here. So yeah, layout choices have to be made at the beginning, and different functions will provide you with different plot types. So meaning routine plots can cause you to have to write a lot of code in order to get the plots that you would like. There is no concept of facets, and what this exactly is, we'll talk about in a couple of minutes. But essentially, you can just have one global coordinate system allowed in your plot. We're not super happy with the default colors that we're using, and resizing can be very, very tricky in base R. And for that reason, we have a much more advanced system that we're using in R these days. So I want to introduce you to the concept of grammar of graphics. This was a concept coined in 1999, and it was an abstraction of all the different elements that are included in a plot or a data visualization. And they were kind of trying to summarize the different levels that a plot can have and the different attributes that you would have to complete data visualization. And that was just theory. But then in 2010, Gplot 2 was developed as an implementation of this grammar of graphics concept. And so this actually builds on the idea that there's independent building blocks to a graph that you can add to each other, and then use that for visualization in R. Brief overview of the different components of the ggplot universe. So we have the first layer, that is the data set, also the noun in the sentence, that is this data visualization language. Then we have these so-called geometric objects, and they are the visual representation of the data. So that's where you're specifying whether you want points, lines, rectangles, whatever it is, histograms, etc. So those are the verbs, so what's being done with the data. And then we have the aesthetics, or the adverbs, and this is instructions on how to map variables to these objects. Then we sometimes have statistical transformations. Then we have a layer that specifies the coordinate systems and the scales. Are they linear? Are they not linear? Are they coordinate? Are they categorical scales, or are they continuous? And then we have facets, meaning dividing one big plot into multiple subplots for better orientation. And then we have some optional parameters for the optics. And I already gave you a quick sneak peek of what this can look like. So down here, you have example code of a plot that I made with Gplot using the Penguins dataset. So in the first line, we have the dataset, the noun, and then with the AES, we have the aesthetics. So we want on the x-axis to be plotted our species, and we want to give the species also as information for it being filled. Then we're using a bar plot, that's our geom, our geometric object. And then we specify the scale that we're using, and then we're adding more information to the theme. And I'm just remembering this now. I wanted to say this in the beginning. All of this code is available on our GitHub. So I will just put the GitHub link in the chat right now, so you can also play around with this code later on. Here is an overview, maybe a rough overview of the different geometric objects that you can find or use in ggplot. For example, you have box plot, violin plot, paths, points, you have smoothed conditional means, different tiles or rectangles, and densities, there's histograms, etc. So these are all basically where you decide what kind of plot type you're going to be using. And I put a link to a cheat sheet here in the corner because I think it's just easiest to have this near your desk when you get started and kind of reference this as you go. And then here we have a more extensive ggplot template again. So this is similar to what I just showed you. So we have the noun or the data set specified at the very beginning. And then we have the aesthetics. So what of the data set are we visualizing? In which way are we visualizing it with the geom type? What are the scales? And then what are we adjusting in the theme? And again, this kind of template is also included in the code that we published to the GitHub. Now, themes can really change the look of these plots. So I made an example here. There's something missing. Okay, so I included more examples in the code, but this is fine. So you imagine that I made a plot with ggplot, and then I can add a command to specify the theme. And so in this case here, I wanted to show you Gplot because I think it really simplifies the way that these plots look and kind of gives it just a simple XY axis scenario and a blank canvas in the back, because the standard ggplots will have the gray background, the many different lines, many different labels. So that's why I recommend sometimes using Gplot. But in the examples I've also included, there's a couple of different themes that come with ggplot. For example, theme minimal, theme dark, etc. There's even some themes predefined for different journals that you might be publishing to. So you can look those up. I know there's one for The Economist, which I don't know if anyone's going to be publishing there. But there's very predefined sets that you can apply to your plots that change a couple of things at the same time, something like background, font size, etc. I also wanted to bring Gplot to your attention because you can use Gplot very well to arrange multiple plots within one bigger plot. So as an example here, I have two different plots, and here you can see really nicely the difference in the different themes. And if I wanted to plot them side by side, I could use this function plot grid that's from the Gplot library to arrange them next to each other, give them separate labels. I could even specify kind of a 1/3, 2/3 split between them, etc. And then you can also create your own theme. Themes work like functions in R, which you might have guessed based on these parentheses here at the end. And so anything that you can change within the ggplot theme, you could pre-specify. So for example, if you're making, I don't know, 20 different plots for a publication, or maybe even 100 different plots for your thesis, you could at the beginning of your work kind of set aside maybe 10-15 minutes to really specify that theme, and then apply that to all of your plots that you're creating as you go along. And then if you wanted to change something to this theme, you could do that centrally in your function, and then again apply it to all of your plots. So there's more information linked on the slide also if you want to look into creating your own. Okay, so in the last webinar, we spoke a bit about what type of plots are appropriate for what type of data. And so we're not going into much detail about this right now. But I highly encourage you to look back into this. And I'm also giving you some resources at the end of this talk for how to know if you should use a box plot or a violin plot, a scatter plot versus a line plot, etc. But one challenge that I think we're often confronted with is displaying more than two-dimensional data. For example, with our penguins, we want to display the bill length, flipper length, but maybe you also want to include the information about the year that the data was collected, or the type of penguin, or the type of island that this was collected on. So what can you do then? And that is when the different options in the aesthetics come in. So, for example, if we're sticking with our scatter plot, we have at least 4 different options of aesthetics that we can use to encode additional information. For example, the color that we're filling the dots with, the shape of our scatter plot. So here in the example, you can see triangles, circles, and squares, the size of the individual data points, and also the transparency of the individual data points. So on the bottom here, you can see an example of this plot of the code that goes into this. And here on the right, you can see all of me trying to put every single piece of information that I have of this data set into one plot. And you can see that this is hypothetically an option. So we have the type, the islands encoded in the shape. We have the penguin species encoded in the color, the body mass encoded in the size of the dot. But while these are really useful tools, I think it's important to not overload your audience and also yourself, because as you can tell, this plot is getting really difficult to understand. There's so much information in it that it can't possibly be processed all at the same time. So some alternatives to visualizing this multidimensional data we'll talk about in a minute. Before that, I want to quickly cover color, and we've also talked about this in the last webinar about how to be inclusive to people who might not be able to perceive all the colors that we're using, etc. But I want to give you some examples of how you can find appropriate colors today. So here you can see the default color scheme in Base R, which is a little bit all over the place, but it'll do fine for some exploratory plots. And then this is the default color scheme in Gplot, which in my opinion isn't great either, because it varies between kind of light and dark hues of the same colors, which can make it really, really difficult if you have many groups and you're trying to visually distinguish them. But there are many, many options out there of where you could get your colors from. One of them being our color brewer that I think provides at least 20 different palettes that you can use for different types of data. So for example, here we have different sequential color palettes. You have some qualitative color palettes, and you have divergent color palettes that you can be choosing from. And I think most of them even have more individual colors available than are originally displayed here. And then these Viridis palettes are also highly recommendable. So what is special about them is not only that they are nice colors, but they're so-called perceptually uniform, which means that the difference between the colors that we perceive is proportional to the Euclidean distance in the color space. And this sounds somewhat confusing, but you can see the example on the bottom. So you have a non-perceptually uniform palette on the left, and then the Viridis palette on the right. And so you can see that you're actually able to kind of gauge the distance between different data points if you're using the palette on the right, as you might be confused with using the palette on the left because the saturation is so different. So you might be thinking more data points belong to one group or are closely related to another. And these palettes are also pretty robust to look at in grayscale, and therefore helpful for color blindness as well. There's some information on a talk here that I really recommend if you're interested in the science behind creating these color scales. So I have mentioned faceting before a couple of times, and I want to show you some examples now. But I think this is a way of how we can display more information than just 2 dimensions of a data set without overloading a plot. So faceting, as you can see here, basically means breaking up a plot into different subplots in order to display more info. So instead of just showing the bill length versus the flipper length, and then coming up with, for example, a different shape or a different color or something for the different years that the data was collected in. Instead, I create these different facets for the different years. So we have 3 similarly structured plots that show the 3 different years. And you can do that with this function facet wrap, for example, and then you just display the variable from the data set that you want this plot to be split by. You can also modify this, for example, if you specify the number of columns that you want your plots to be arranged in. So for example, here I specify 2, and then that leads to me having at max 2 plots next to each other as opposed to beforehand. You can also do this for multiple dimensions again. So on the right, for example, I split both by year, but also by island. So I'm actually creating a grid that makes a plot for the combination of each year with each island. And I'll break it up this way. And the command for that is the facet grid command. And then I specify basically the horizontal versus the vertical split variables. And now I want to introduce you to the idea of interactive plots. They can also be super helpful if you're trying to visualize more dimensions than you can comfortably do in a static plot. Or if you want to actively interact with the data that you're visualizing and exploring it as you go. So I will try to show you some examples here in a minute, but platforms that really lend itself to this cause specifically for R, Plotly, which I'm going to show you in a minute, and they also work with Python as well. Shiny is a way of creating apps that are interactive, and we'll look at an example in a minute as well. And there's also GHGA Animate, for example, that allows you to kind of make time-dependent plots. So I could, for example, make an animation of my Palmer Penguin data over the years, where I display a different plot every couple of seconds over the years. If that might be something that's interesting for a presentation or something. And then there's also the idea of linked charts, and I'm just leaving the resource here because I think that's a little bit more of a complex setup. So here, for example, we're on the Shiny website. The link is included in those slides. And if you just scroll down, you see a very basic, easy app. This is actually nowadays completely coded in one R script, if you're so inclined. And you kind of have an UI component, and then you have a server component as well. And what you can maybe see kind of on first glance is that you can also use Gplot within these Shiny apps. And so this is kind of an example of what this could look like. So again, they're using the Palmer penguins. And you can here, for example, dynamically adjust what you want to have displayed on the X and Y axis. And you can even check or uncheck what kind of species of penguins you want to have displayed. So that's kind of an option for like a dynamic interactive visualization. What you cannot do here, for example, is click on these individual data points and get more information. But that's something that Plotly can do. So I will show that now. Yeah, so Plotly is, I said that already, is for interactive data visualization, but it also comes as a collaborative platform for data science. So there's actually a user community on this website where you can upload plots to, you can collaborate on plots, etc. And they can do interactive things. They can even do 3D plots. You can zoom into it, you can rotate it. And what's really cool is that you can actually translate ggplot code directly to a Plotly graph, because Plotly itself, unfortunately, doesn't follow the grammar of graphics. So there's a really cool book linked down here that would be a very good primer if you're interested in creating your own plots. What's important to know, or what I use, is RStudio for this, because you need some sort of environment where you can generate them and look at them. And RStudio nowadays can generate them as you go in RStudio as well. And if you were to share them or publish them, I think most likely you would want to save and distribute them as HTML files. So here's an example of one of these plotly plots, and maybe at first glance they look very similar to the ggplot. This is a screenshot, but we'll go into the interactive version in a second. But what you can see is that you can hover over these different data points and then gather more information. And you can actually also program these hover functions to include whatever information about the data that you would like. And you can see some functionality up here about taking screenshots, zooming in, zooming out, resetting the axes, etc. So here on the left, you have an example of the conventional Plotly code that does not follow the grammar of graphics. But below here is an example of how you can make a full ggplot with all the customizations that you would like, and then use the function ggplotly to convert your ggplot to an interactive plot. So we'll briefly look at this in my RStudio. So this is also shared in the GitHub, by the way. We have this conventional Plotly code that I just showed you. So if we display that, we get this interactive plot where I can hover over these different data points. And I can, for example, see that this is a chinstrap data point, this is a Gen2 data point, and even the values that went into plotting it. I can try to zoom in on it, which is going to change the axes. And then I can also, I think here, auto scale and reset the scales. And then down here, we have this, what I just showed you. We have this full ggplot code that I can then use with ggplotly to convert into this highly customized plot. And so here you can see when I hover over it, I can see the flipper length, the bill length, the species, etc. And so this is set up in my RStudio, but what I can also do is knit this into an HTML file, and then that would look, so here I rendered this HTML file into, this markdown file into an HTML file, and I didn't adjust a lot of settings, so we're seeing all of my code here. But this is, for example, what the plot would look like if you were trying to send this to a collaborator as an HTML file, where you can put this on your website, etc. as well. One last point that I didn't mention in my outline today is that I wanted to briefly talk about using ChatGPT when you're doing data visualizations. So my question here, could you raise your hand if you've used ChatGPT in the past for programming or any other scientific tasks? Okay, yeah, so I'm seeing some expertise here already. Thank you so much. So I'm probably not telling you anything new when I'm telling you you can use ChatGPT to write code for data visualization. Personally, I've experienced that it's a little bit risky and you may be introducing bugs to your code. But what you can do very reliably is using the code that you already have and letting ChatGPT make adjustments to it. So for example, here I pasted in the code that I already have, and I just asked ChatGPT to change the color palette, for example. And that's something that I think it can do very reliably. So you are probably familiar with this, but it even gives you the code in some sort of like mock-up console or command line look, and you can copy that code directly and then execute it in your RStudio or whatever environment you're using, and be a little bit quicker when it comes to visualizing your data that way. So that was enough talking about R for now.